All right, so in order to solve IVPs with Laplace transform, I need at least one tool that I don't have yet, which is really, I'd like to be able to solve second degree differential equations, right? Like this tool should be at least as useful as the one I had before. So I probably need to know how to Laplace transform y double prime. You guys with me on that? So you guys remember how to Laplace transform y prime?
Yeah.
Oh,
Yeah.
yeah.
Yeah?
S, Y,
You get S, the Laplace transform of y,
Plus y naught.
Y,
Or y of 0.
Y evaluated at 0.
so there's definitely a y evaluated at 0,
Minus Y evaluated.
Minus.
and it's minus. And you get this from, like, where does this come from?
Doing parts on that.
Yeah, this comes from integration by parts. Oops. And there's a little weird assumption in there. What's the little weird assumption in there?
S is something.
S is something big. Yeah, kind of. That you can Laplace transform y at all,
Yeah.
right? Like, that's a heavy lift. There's no reason to assume that's true, right?
Right.
But existence and uniqueness theorems would indicate that if you did this and it worked and you found something, then if you plug it back in and check, that's going to be the one and only one solution, right? You guys see that? So you need a little bit of a lift from an existence and uniqueness theorem to show that this was kind of the only way to solve this. That make sense? Because otherwise that assumption's totally unjustified, and the only way to be sure would be to plug it back in and check at the end. Let's go that. That said, it works, so have that. So the other one I needed was the Laplace transform of y double prime, right? And I claimed that you could get this by doing integration by parts twice. But why?
Yeah, how about we just,
How about we just?
well, we have the Laplace transform of y prime, so instead of, S Laplace of y minus y is 0, it would be S Laplace of y prime minus y prime is 0.
Cool. Oops, wrong symbol. So you're thinking of y prime, y double prime as y prime prime, right?
Mm-hmm.
Yep, totally. Then apply the previous. So you get S Laplace transform of y prime minus y prime at 0.
You also need to add some over that.
And then you know the Laplace transform of y prime.
Yeah.
It's that. So you put that in there. So you get S times S Laplace transform of y minus y at 0
Minus y.
Minus y prime.
minus y prime at 0. Perfect. So all told, you arrive at this kind of nifty formula, which you want to add to the place near that one, which is that the Laplace of y double prime is S squared, the Laplace of y, minus sy at 0, minus y prime at 0. That's cool then? So these two lines, this whole business here, should go in your, like ideally it would live on your Laplace transform sheet, right? The author, for whatever reason, didn't include that, but these would be a good spot for that. Ideally you would get this, yeah. A good spot for this tattoo is right along here. And I'm always willing to let you use tattoos on exams, but I will check to see that they're actually tattoos. I told you guys about my physics buddy. I have a buddy who's a physics PhD, and he got, during graduate school, a whole shitload of stuff tattooed on his arms. Like he has Maxwell's heat equations and a bunch of physics equations that he uses fairly often, tattooed all over his arms.
Did they have a problem with that?
No,
No?
no, everybody was like, yeah, sure.
You did? You went
Like,
for it, dude.
you went for it, good work. Also, it's not like you're gonna screw up Maxwell's heat equations on your PhD quals,
Yeah.
right?
I would hope not.
Well, okay. I say that, but then I remember that one of my buddies screwed up the quadratic formula on a master's qual, so he was just really nervous, I think. Anyway, add these two things to your list of stuff.